There is no proof for the second law of thermodynamics. This is true. There is no rigorous mathematical proof for the second law. Now, why is that? Okay, strictly defined, mathematical proof or physical proof for the second law would have to come from a set of assumptions, a mathematical model, manipulation of these equations that would lead to some algebraic result that shows you the second law. So what is the second law? The second law essentially says that entropy always increases with respect to time in some closed system. So if you account for all of the energy expenditure in some space with respect to time, as it relates to the disorder in those particles, the system gets more disordered. Things point in different directions, they move all over the place, they don't tend to settle down in one place, and a lot of this relates to the definition of entropy itself. Entropy is a quantity that you really learn about first. Well, you learn about it pretty early on, but you really dive into the deep end of it in statistical mechanics. Now, statistical mechanics has to do with probabilistic aspects of motion. So if you take a bunch of particles of, say, a gas and put them in a box, they tend to spread out, they tend to all point in different directions, they move at different speeds, they bounce off of each other, they bounce off the walls, this kind of thing. Then you would expect the system to be pretty chaotic. It's very unlikely for them all to bunch up into the corner of the box and all be pointing in the same direction and moving at the same speed or moving with no speed at all. And that's exactly the way entropy is defined. It's proportional to the number of microstates, available microstates, to a system at a given macrostate. The box is at room temperature, 70 degrees Fahrenheit, and it's a box full of air, let's say. Particles of air in a room tend to spread out. That's why when we walk around, we have no problem breathing as we move from one space to the next. All the particles of air spread out relatively evenly. And so, for air at 70 degrees Fahrenheit, what Boltzmann essentially said was that system exists such that the number of microstates, all the possible states those little particles could be in, is maximized. So some particles could be pointing in one direction, some particles could be pointing in another direction, they could be moving at different speeds, they bump into each other. If you were to take a snapshot, just a moment in time of the particles in that space, you would expect them to be pointing in different directions and moving at different speeds. And you put it into an equation, it's S equals K times the log of W. The S is the entropy, K is a constant called Boltzmann's constant, and W is the number of available microstates. And this is why there's no strict mathematical proof for the second law, because the number of available microstates is very difficult to count, it's very difficult to capture even in a laboratory setting, and so you can prove it experimentally, but to sit down and write a strict mathematical proof is, I don't know if it's necessarily impossible, but it's definitely exceedingly difficult because of the definition of entropy itself.